All right, so here's a question where we're trying to evaluate a limit. Because there's a ratio here, you might run into a problem if you just insert this number into the function, because there might be a restricted value, there might be an asymptote, there might be a gap, right? And so if this number represents a restricted value for x, then you have to go a step further, which is the case, right? So let's take a look. 3 minus 2 is 1. Square root of 1 is 1. Minus 1 is 0. So right away we know we get a 0 on the bottom. It doesn't really matter what happens to the top. It's a 0 on top as well if we just plug 2 in. So we have an issue there. 0 over 0 is an issue. So one of the things that you can do to try to manipulate this is multiply the top and the bottom by something that's the exact same, so as not to change this function, but just to change how it looks. And one of the things that we talked about earlier is to rationalize either the numerator or the denominator. So you could try rationalizing the denominator to see if we can get something other than a 0 in the denominator. Okay, that's what I would suggest you doing first. So what you do to rationalize is you multiply by the conjugate. Okay, so root 3 minus x minus 1, the conjugate would be root 3 minus x plus 1. And of course you'd multiply top and bottom by this right here. So what we want to do then is we want to test to see if this solves our problem. So again, and I haven't mentioned this yet, I don't think, but when you're doing these limit questions, you need to rewrite this portion, the limit portion, you need to rewrite that every step. So when you do your work, you need to rewrite this every step, okay? I've seen students not do this. They get halfway down the page, because some of these take a long time, and then they kind of forget what they're doing. They think they're just simplifying, and they leave a simplified expression, which is not right at all. Plus, when you're showing your work, you want to communicate to yourself and whoever's looking at this, that you are still understanding that you have to evaluate the limit yet, that you're not at the next step. So we want to rewrite this. Now, we want to focus on the denominator here, because this will yield us a difference of squares in the denominator. So I'm just going to evaluate that one first. Root 3 minus x squared is just 3 minus x. And when you multiply these together here, because they're conjugates, you're going to get minus 1 here. Okay. Now, does this solve our problem? So I will rewrite this. Let's just rewrite this, but let's not expand it for now. So let's rewrite this as the product here, okay, with the factors. So does this solve our problem? Now, if you insert 2 into here, do you still get a 0 on the bottom or something different? Well, 3 minus 2 minus 1, that's still a 0. So we still have an issue here, don't we? Okay? So what we're going to need to do is we're going to need to go a step further. We need to do another sort of rationalization. And what we're going to do, I'm going to take you back to this step here just to kind of show you what we're going to do. We are also going to rationalize the numerator. So I'm going to multiply by another piece here, which is the root 6 minus x plus 2 over root 6 minus x plus 2. Okay? So down in this second step here, and I'll put this in blue, and we're going to have this on the bottom. I'll leave that alone. We'll put root 6 minus x plus 2 as a factor in the bottom, and I will show it here as well. Okay, let me just clean some of this stuff up here for now. Okay, original question and our work so far. All right, so what does this do? This looks like a little bit of a mess here now, but we understand that this is going to be a difference of squares when we multiply those out. Sorry, that should be plus. And so this is what it's going to start to look like here. Okay, this times this right here, difference of squares, which is going to be 6 minus x minus 4 when you multiply negative 2 times positive 2. Okay, down here you're still going to have this right here, 3 minus x minus 1. And then you're going to have these two things right here, these two factors, 3 minus x, this is not going to cancel out with anything. Okay? All right, so we still have this in the bottom, which is a problem, and we also still have this, which is also a problem in the numerator, but watch this. When you simplify these two right here, you get what? What's 6 minus 4? That's 2 minus x. And what's 3 minus 1? 2 minus x. So what you should see here is that we have factors that are the same in the numerator and the denominator, and we can divide those out. So you do not have to plug x in here at this stage. We're still kind of doing this manipulation. So those factors can be eliminated. They're gone. And then you're left with just this right here. Now we do a quick test on 2 here. 6 minus 2 is 4. Root 4 is 2. 2 plus 2 is not 0. So we're in good shape. This is when you can drop the limit sign now. Okay? So you can drop the limit sign because you're now just substituting 2 in here. So if you substitute a 2 in there, the value of this is going to be the limit, right? Because it's not a restriction anymore. And so this is a continuous part of the function now, basically, and you can evaluate it at the limit. So this is going to be root 3 minus 2 plus 1 over root 6 minus 2 plus 2, which is root 1 plus 1 over root 4 plus 2. So that's 1 plus 1 is 2. This is 2 plus 2 is 4. So the limit is 1/2, and that should be your answer. So bottom line is that you have to rationalize both the numerator and the denominator at the same time for this one in order to eliminate this problem factor of 2 minus x. Okay? All right. So that's a tricky one. That was 9b from section 1.2.